leads by 90 degree. Now the question number 5. Determine the output V naught of the following circuit figure 5. Note X symbol indicates analog multiplier. Here again, it's a inverting amplifier, inverting summing amplifier. At the inverting amplifier, we have two inputs, Vs1, Vs2. And at the feedback, I have multiplier, and the input side also I have multiplier. Multiplier will multiply two input signal. Okay, so at the input side, I have Vs1 that is applied to the multiplier. The input terminals of the multiplier is shorted, so that both the terminals are Vs1 only. So it is a squarer, Vs1 square. Similarly, in second case also, it is Vs2 square. Now both are added at the inverting terminal. So the voltage at this point or the voltage at this point, both will be same. That is nothing but what? Vp equal to minus of Vs1 square plus Vs2 square. Okay, now come to the output side. Output side we have V naught. V naught is applied to the multiplier, this multiplier. Okay, so that is related to Vp. With respect to V naught, what is Vp? Vp equal to V naught square. So both are just we are equating both terms. So V naught square equal to minus of Vs1 square plus Vs2 square. From there, what is V naught? V naught equal to square root of minus of Vs1 square plus Vs2 square. The option is C. Question number 6. What happens if the input voltage is higher than the reference voltage? Vi is greater than V reference in a positive clipper as shown in the figure. In general, what do you mean by positive clipper? Means, let's assume this is my input signal. Okay, this is my input signal. Positive clipper means some positive portion will be removed. That is called positive clipper. Okay, whenever the input voltage is greater than the reference voltage, some portion will be removed, which means, let's say this is my reference voltage. Whenever my input is exceeding, that will be removed, and Vi output will be equal to V reference. Okay, so now the question is, when Vi is greater than V reference, the output voltage will be equal to reference voltage. When we will have output voltage will be equal to input voltage, means when Vi is less than V reference, we will have this case. Okay, now the question number 7. What is the output voltage V naught for the following circuit, where R equal to 10 kilo ohm and input current is 10 nanoampere, Va equal to 5 volt, and operating temperature of the diode is 300 Kelvin. Okay, so for this, when the diode is available at the feedback path, then the output voltage V naught can be written as minus eta Vt into ln of Vi by R minus ln of In. Okay, so ln A minus ln B is nothing but ln A by B. So minus eta Vt ln of Vi by In into R at the denominator. So here eta equal to 1, minus into 1, and Vt at a 300 degree Kelvin, Vt will be 26 millivolt. So it is 26 millivolt. Ln of Vi is equal to 5 volt divided by In is 10 nanoampere into R is 10 kilo ohm. After substituting all these values, if you use calculator, you will get the value minus 0.281 volt. This will be output V naught. The last question is, it's a full wave rectifier. What is the value of V naught during the positive half cycle and negative half cycle respectively? So rectifier means what? When you have input voltage which is swinging between positive and negative, means output voltage will be only positive. That is called rectifier. Okay, so it's a full wave rectifier, so that positive and negative both will be available at the positive side. This is Vi and this will be V naught. Okay, so it's a precision rectifier, which means that there is no cutoff voltage for this because of the diode D1 and D2, so that the output will be for positive cycle, the output will be V naught equal to Vi. For negative cycle, the output equal to V naught equal to minus Vi. So option D. Thank you.